Hello students, how are you? Hope so you have completed your 10th standard in a great manner. So let us enter into our 11th standard mathematics. So I feel so definitely you have learned the topic matrices in your 10th standard itself. So I thought of going with the preliminary concept of matrices. So with that entering into other chapters for 11th standard. So in 10th standard itself you would have learned what is a matrix and how do they perform, what are all the different kinds of matrices, and then how to write a matrix, how to perform operations in matrices, how to perform arithmetic operations in a matrix, row addition, then subtraction of a matrix, addition of a matrix, then product of a matrix. You will apply row column multiplication to find product of a matrix always. So now let us also in 11th standard, let us all recapitulate what all you have learned in 10th standard. Then with the help of that, we will enter into our 11th syllabus. So first chapter, we are going to start with the topic matrices and determinants. Matrices and determinants. So in the 10th standard, you have learned only matrix. So with the help of that, now we are going to get upgraded to 11th standard with the topic determinants also. Matrices and determinants. Matrices and determinants. Okay, fine children. So any idea regarding a matrix? What is a matrix? Any idea you have? So a matrix is nothing but a rectangular array or arrangement of elements in rows and columns. A matrix is a rectangular array or arrangement of elements in rows and columns. So let us, and the matrix is denoted by only by capital letters A, B, C and so on. Now let us denote the matrix A equal to, and all those elements are being put in only with the square brackets. All the elements of a matrix are put only within a square bracket. So A equal to, let me write the general form of a matrix. So A11, A12, etc. A1n, A21, A22, etc. A2n. It goes on AM1, AM2, etc. AMN. This is the general form of a matrix. So all the elements of this matrix, all these are arranged in array in rows and columns, and it is denoted only in the square bracket. Fine. Now, how to find the order of a matrix? How to find the order of a matrix? Now, this matrix A, its general form is Aij. Matrix is denoted like this, where 1 less than or equal to I less than or equal to M, 1 less than or equal to J less than or equal to M. The value of I goes with M and values of J goes with M. Now how to find the order? Now here horizontal elements are called as rows and the vertical elements are called as columns. Horizontal entries are called as rows, vertical entries are called as columns. Now here I have a matrix of order M cross M. So Now, suppose if I have a matrix of elements 12. If I have a matrix of total elements 12. Now, how many elements I have here? Total number of elements inside the matrix is 6. Now, 2 3s are 6. Suppose if I have total number of elements in the matrix is 12, what are all the possible orders I can have? My question is, if my total number of elements inside the matrix is 12, what are all the possible orders I can have? So, what are all the possible orders? My possible orders is nothing but the product of rows and columns. So, what product of ordered pair natural numbers? You should write it in an ordered pair natural number. So, suppose if we have 12 elements, what are all the possible orders? My orders should be an ordered pair natural number. So, possible orders are 1 cross 12. I can do one row, only one row, but 12 columns. Next possible 12 rows and 1 column, 12 cross 1. The next possible order is 2 cross 6. So, in what all way you multiply the product of rows and columns, your result should be 12. What are all the natural numbers? You multiply so that the product should be 12. 2 cross 6, 6 cross 2, 3 cross 4 and 4 cross 3. Is there any more order possible other than this? So what are all the natural numbers you choose and multiply, you should get the product as 12. Is there any more orders possible? No, only with this we don't have any other orders possibilities for the product 12. Fine. Now with this, let us enter into the types of matrices. What are all the different types of matrices? Let us get into detail. First one is row matrix. So what is a row matrix? Row matrix is nothing but which contains only one row. This is a row matrix which contains only one row. A matrix is said to be a row matrix if it contains only one row. Now second is column matrix. So matrix is said to be in a column matrix if I have only one column. If I have elements inside the square bracket as a one column, single column, this is said to be a column matrix. Now, the third thing is, so we have seen row matrix and column matrix. Now, what is a square matrix? What is a square matrix? A square matrix is said to be, a matrix is said to be a square matrix if the number of rows is equal to the number of columns. My number of rows and number of columns are equal, then that matrix is said to be a square matrix. A square matrix of order n cross n is n. A square matrix of order n cross n is n. So let me go ahead with the example. Now this is a square matrix because my rows 3, my column is also 3. So now I have a square matrix of order 3 cross n. So order of this matrix is 3. Order of n cross n is n. Similarly, order of this 3 cross 3 matrix is 3. Follow? Fine. Now with the help of this square matrix, let us enter into what is a diagonal matrix, what is a scalar matrix, what is a unit matrix, and what is a triangular matrix. So before getting into all those kind of matrices, let us see what is a zero matrix. What is a zero matrix? A matrix is said to be a zero matrix if all the elements inside the matrix are zero. That is my all the elements inside the matrix will be of 0 for all values of ij. For all values of 1 less than or equal to I less than or equal to m, 1 less than or equal to j less than or equal to n. For all values of I and j, all the elements inside the matrix will be 0. So I can have this kind of zero matrix. I can have this kind of, so this kind of zero matrix. Here my order is 2 cross 2 and here my order is 2 cross 3. If at least one of the entry is non-zero, at least one of the entry in matrix A is non-zero, that matrix is called as non-zero matrix. If all the elements are 0, it is called as zero matrix. At least one element is non-zero, then it is called as a non-zero matrix. Okay. Now we have already seen scalar matrix. With the help of square matrix, let us get into what is a diagonal matrix. Now, the other name for zero matrix is nothing but I can say null matrix, void matrix. Null matrix and void matrix. Now, let us get into diagonal matrix. Now, diagonal matrix is nothing but where the principal diagonal, where the diagonal elements, I should have all the other values except the diagonal elements equal to 0. So, my A equal to Aij. My diagonal matrix is nothing but a square matrix. A of order n. Here, I have zeros. I have values if I equal to j and 0 if I not equal to j. So, the example for the diagonal matrix is this is the example for a diagonal matrix. This diagonal matrix is also called as principal diagonal, main diagonal or the leading diagonal. All the elements in the diagonal will be, I have some values if I equal to j. Here A11 I have some value, A22 I have some value, A33 I have some value. Rest all the values will be 0. So wherever I have I not equal to j, I have zeros. So apart from I not equal to j, if I have I equal to j, those places will we have some numbers, either some natural number or a whole number or a rational number or a complex number or a trigonometric value, whatsoever may be. Now this is called as diagonal matrix. Now this diagonal matrix, so every square matrix is a diagonal matrix if the diagonal elements are equal to some value other than the remaining values, the rest of the diagonal elements, everything will be equal to 0. Now, with the same diagonal matrix, we are going to learn what is a scalar matrix. So, a diagonal matrix is said to be a scalar matrix if all my diagonal elements are equal to same value, are equal to same number. Say for example, all my diagonal elements here, everything is equal to 3. So here I can write my A equal to Aij, same square matrix will be equal to 3 if I equal to j, 0 if I not equal to j. I can define like this. So a diagonal matrix is said to be a scalar matrix if all my principal diagonal elements are equal to some value. Now with the same diagonal matrix, what do you mean by a unit matrix? So a matrix A equal to Aij of order n cross n is said to be a unit matrix if this is equal to 1. If I equal to j, wherever I have I equal to j, I have value only 1 and 0 if I not equal to j. So the values of diagonal elements, if it is equal to only 1, all my main diagonal elements are equal to 1, that matrix is called as a unit matrix. So example, unit matrix is also called as an identity matrix. So 1 0 0 1. This is called as an identity matrix. Since this is an identity matrix, is also denoted as I. Identity matrix is also denoted as I. Now this is an identity matrix of order 2. Now this is denoted as I2. Say for example, if I have like this. This is an identity matrix of order I3. So if all the principal leading diagonal elements are equal to 1, that is A11, A22, A33, if it is equal to 1 and the rest of the values are 0, that is called as unit matrix. Now next, now what is a triangular matrix? Now we have two types of triangular matrix: upper triangular matrix and lower triangular matrix. A matrix is said to be an upper triangular matrix if we have elements below the main diagonals are 0. Below the main diagonals are 0. So a matrix is said to be an upper triangular matrix, that is A equal to Aij of order n cross n is said to be an upper triangular matrix. So here I have will be equal to 0 for I greater than j. Will be equal to 0 for I greater than j. So say for example, now this is my main diagonal. This is my main diagonal 8 to 5. Now the elements below the main diagonal will be completely 0. Elements below the main diagonal fully will be 0. That is called as upper triangular matrix. Now what is lower triangular matrix? So lower triangular matrix is nothing but you will have zeros above the main diagonal. You will have zeros above the main diagonal. Say A equal to Aij of order n Let me have main diagonal. I have here -1, 2, 4 as my main diagonal, and all the elements above the main diagonal will be 0, and I have some other values below the main diagonal. If all the elements above the main diagonal are 0, it is called as lower triangular matrix. Lower triangular matrix. A matrix which is either upper triangular or lower triangular, that matrix is compulsory called as generally a triangular matrix. A triangular matrix. Now, so we have seen all different kinds of matrices: row matrix, column matrix, zero matrix, square matrix. With the square matrix, we have seen diagonal matrix. With the help of diagonal matrix, we have seen scalar matrix, unit matrix, and triangular matrix. Now, let us get into what is an equality of matrices. Say, I have two matrices A equal to Aij and B equal to Bij. When can I say these two matrices are equal? Only if both A and B are of same order, and second condition is the corresponding entries of A should be equal to the corresponding entries of B. The entries of both the matrices should be equal, as well as both the matrices should be of same order. Suppose if any one condition does not satisfy, then automatically equality of matrices does not hold good. Does not hold good. Suppose if I have here 2 cross 2, here also 2 cross 2. My order here is 2 cross 2, here also 2 cross 2. I am going to equate the corresponding entries. So here my value of x is equal to -1, y equal to 3, z equal to 5, a equal to 0. I am able to find out all the unknowns since the corresponding entries are equal for equality of matrices. Follow, children. So with the help of all these matrices, kinds of matrices, everything, because we have still more introductions. So relatively we will go ahead with the exercise problems. Now let us get into exercise 1.1. Okay children, now let us get into exercise 7.1. 7.1, actually we are doing the second one. Exercise 7.1. So first one, second subdivision, Aij they have given. Now they are asking us to construct the n by n matrix. Modulus of 3a minus 4b. This is modulus by 4. n equal to 3 and n equal to 4. So they are asking for, I have a matrix of order m cross n. So here I am going to have an order 3 cross 4. 3 cross 4. So 3 cross 4 means I should have 3 rows and 4 columns. So what is my Aij? My Aij should be 3 rows, 4 columns. A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. I have 3 rows and 4 columns. So I am going to construct a matrix where my elements are given by modulus of 3i minus 4j by 4. So I need to take A11. In place of I and J, I will substitute 1, 1. My first element, my first A11, my first element denotes the values of I. My second element denotes the values of J. So A, I, J, I denote my first element, J denote my second element. So replacing that according to this given question, we are going to construct the matrix of 3 cross 4. So my order here is 3 cross 4. Now what is my A11? So 3 into my I is 1 minus 4 into my J is 1 by 4. Okay. So here 3 ones are 3 minus 4 by 4. What is 3 minus 4? Minus 1. But since I have modulus, what do you mean by modulus? Modulus is nothing but if I give positive or negative value, the result is always going to be positive. The result is always going to be positive. So 3 minus 4 minus 1. Since I have modulus plus 1. So 1 by 4. So my first value is 1 by 4. Next, first we will find row wise, then second row, then third row. So it is easy for us to replace back this matrix. Now A12, my I is 1, J is 2. So determinant of 3 into 1 minus 4 into 2 by 4. So modulus of 3 minus 8 by 4. 3 minus 8 minus 5. One positive, one negative. You will subtract and write the greater number sign. So minus 5, modulus of minus 5 is plus 5 by 4. Now next, A13. My I is 1, J is 3. Modulus of 3 into 1 minus 4J. 4 into 3 by 4. So modulus of 3 minus 12 by 4. 3 minus 12 is minus 9. Modulus of minus 9 by 4. Now let me proceed on to A14. My I is 1, J is 4. So modulus of 3 into 1 minus 4 into 4 by 4. So modulus of 3 minus 4 4s are 16 by 4. 3 minus 16 minus 13. Modulus is plus 13. So 13 by 4. Follow children. So I have completed the first row. A11, A12, A13, A14. Now let us get into the second row. A21. So A21. Now here my value of I changes. I to J1. So modulus of 3 into 2 minus 4 into 1 by 4. 6 minus 4 by 4. 6 minus 4, 2. So 2 by 4. I can reduce just 1 by 2. Now what is my A22? Modulus of I and J, both the values are 2. 3 into 2 minus 4 into 2 by 4. So modulus of 3 2s are 6 minus 4 2s are 8 by 4. 6 minus 8 minus 2 by 4. But modulus, so 2 by 4. That is nothing but I can write it as 1 by 2. Similarly, let me go ahead with A23. Modulus of 3 into 2 minus 4 into 3 by 4. So modulus of 6 minus 12 by 4. 6 minus 12 minus 6. Modulus is 6 by 4. I can reduce it as 3 by 2. Now A24. So modulus of 3 into 2 minus 4 into 4 by 4 equal to 6 minus 16 by 4. 6 minus 16 minus 10. Modulus is plus 10 by 4. If I reduce, I get 5 by 2. Now here with this I have completed the second row. Let me get into third row. A31. So A31 is modulus of my, again now my I-value changes, I3J1. I3J1. So 3 into 3 minus 4 into 1 by 4 equal to modulus of 3 3s are 9 minus 4 1s are 4 by 4. 9 minus 4, 5 by 4. A32. So modulus of 3 into I3J2. So 3 into 3 minus 4 into 2 by 4 equal to modulus of 9 minus 8 by 4 equal to 1 by 4. Now A33 modulus of 3 into 3 minus 4 into 3 by 4 equal to modulus of 9 minus 12 by 4. 9 minus 12 minus 3 modulus, so 3 by 4. Now A34 modulus of 3 into 3 minus 4 into 4 by 4 equal to modulus of 9 16 by 4. 9 minus 16 minus 7. Modulus becomes plus 7 by 4. Now what is my Aij? So with this I also have completed third row. My first row is A11 1 by 4. We got A12 5 by 4. A13 9 by 4. A14 13 by 4. Now A21 is 1 by 2, A22 is 1 by 2, A23 is 3 by 2 and A24 is 5 by 2. A31 5 by 4, A32 1 by 4, A33 3 by 4 and A34 7 by 4. So I have constructed a matrix for modulus of 3a minus 4j by 4 for order 3 cross 4. I have 3 rows and 4 columns. So I have constructed a matrix of order 3 cross 4. Follow children? Any doubts? So exercise 7.1 first sum, second subdivision we have done, and I hope so the same kind of problem you have learned in your 10th standard. So first subdivision is very simple. I wanted to complete that problem alone as homework. First subdivision alone I want you to complete as homework. Now let us get into second problem. Let us get into the second problem. We are supposed to find the values of P, Q, R and S. Already we have learned what is the equality of matrices. So two matrices are said to be equal if they both are of same order. Here order is same 3 cross 3. Here also order is same 3 cross 3. And the corresponding entries are equal. If I am able to equate the corresponding entries equal, then I say these both are in. These both come under equality of matrices. So using equality of matrices, I am going to apply and find unknown P, Q, R and S. Now, corresponding entries are equal. So let me P square minus 1 equal to 1. P square minus 1 equal to 1. So what happens? P square equal to 1 minus 1 when I take here plus 1. So P square equal to 2. So value of P is plus or minus root 2. Because plus root 2 if I square also I get 2. Minus root 2 if I square also I get 2. So my value of P is plus or minus root 2. Next, How to find Q? Q I have here minus 31 minus QQ equal to minus 4. Keep minus QQ as such. Minus 4 plus 31. Minus QQ equal to 31 minus 4, 27. So QQ equal to minus 27. QQ equal to minus 27. So Q equal to cube root of minus 27. Cube root of minus 27. What is cube root of minus 27? Let me add a minus here. So cube root of 27 is nothing but 3. So value of Q equal to minus 3. Similarly, I have A2 to us R plus 1. Here 3 by 2. So to find the value of R plus 1 equal to 3 by 2. So my value of R equal to 3 by 2 minus 1. So R equal to, taking LCM, because I have a fraction of the whole number. So only by taking LCM I can find the value of R. So 3 minus 2 by 2. So R is equal to 1 by 2. My value of R is 1 by 2. Similarly, S. To find the value of S, last element A3, S minus 1 equal to minus 5. So S is equal to, keep minus by as such, plus 1. So value of S is 1 minus 5. So my value of P is plus or minus 2, Q equal to minus 3, R equal to 1 by 2 and S is equal to 1 minus 5. All our children, any doubts? So only first problem, first subdivision I wanted to complete as homework. If you have any